Hi, everybody. Thanks for joining us this morning. We're going to be walking you through how you can use Trifecta to create a modern big data customer 360 profile. My name is Carreras, and I'm a customer success manager at Trifecta, and I'm joined by Quoc Tran.
Hi, this is Quoc Tran. I'm Director of Sales Engineering for Trifecta.
So what you're going to see today is an explanation of one of our most interesting customer use cases. This is from Royal Bank of Scotland, and what they've been able to do with Trifecta is actually create a very interesting customer 360 profile. And Quoc, after we walk through how this worked, he'll actually be giving you a demo that's based on that use case. And we'll have some time for questions at the end, so if you do have any questions, feel free to send them along through the WebEx. So before we dive in, I just want to give a quick introduction to Trifecta. You can see that our main goal is empowering businesses to innovate with data. We're fundamentally a data wrangling company, so we're focused on allowing people who know the data best to work with the data and to get value out of data. Some of our customers, you can see on this slide, we do have some of the largest organizations who use Trifecta for their initiatives. You can see that a number of these customers are actually also doing Customer 360 initiatives. So we've heard a lot about Customer 360 over the past decades. This is not something new, but what makes it particularly meaningful today and particularly interesting today is the surge of new digital technologies that are adding what we call the digital voice into the conversation your customers are having. So if you think of all the ways you interact with companies and services today, it's not just through traditional channels like going into a branch of a bank or dialing a customer service line. You might also be using a self-service website, live chatting with service agents, tweeting if you're particularly frustrated with service, even going to online forums and social media like Facebook. So there's this huge deluge of new sources for customers to talk about your organization's services and provide feedback. The biggest challenge is that if your organization is still only using the traditional set of sources, so things from your enterprise data warehouse or your customer relationship management system, traditional relational sources that you've had access to and have been analyzing for a very long time, you're missing a key component of how customers view and interact with your brand that provides you with a much richer understanding of what your customers need and what they want. And so in order to build an overall picture of your users, what you want to understand, and what we're seeing a lot of Trifecta's customers now trying to understand, is why a customer uses a particular channel and how their journey with the organization changes over time. And the best place to get these types of data and interactions is through new media, new digital technologies. So for the RBS case in particular, we've pulled a quote from an interesting study, which is web-based self-service has surpassed both in-person contact and call center as the most used service option. So if this is something that you're excluding, you can imagine that there's a very large set of interactions that you have no context around. Of course, if you're looking at these new media technologies, the data that you're getting from them is not clean. It's messy and diverse. So you might be getting a JSON file. You can see one of those in the background here. Not something that, if you're a business analyst, you particularly want to deal with or have the tools to work with effectively. So lots of data and lots of particularly messy, unstructured data. A Forrester study recently said that organizations only use 28% of their semi-structured data and 31% of their unstructured data. And that's precisely because this data is very challenging to use. It's not formatted in a way that easily fits into something like Excel, or that you can get into an enterprise data warehouse without a large amount of munging and transforming and massaging. And so if you think of the people who want to put together the customer 360 and really understand what's going on with the customer, these are not necessarily your most technical staff members. They may know the data the best, but they may not have the technical coding skills necessary to write Python or R scripts to unpack or structure those complex files. And so if you think of the traditional data analytics process, in the old world, and sort of the ideal scenario is you have a question about your data. You then access your data, are able to analyze it, and come up with an insight. However, if we think of that messy data, this really throws a wrench into the old school data analytics process. Because now, instead of being able to immediately analyze your data, you have to do work beforehand. And that's where Trifecta comes in. So in order to get the most out of all of your new data sources, whether they're structured, unstructured, semi-structured, regardless of the channel they come from, data wrangling is essential. So you can see that data wrangling consists of a set of actions to discover, structure, cleanse, enrich, validate, and ultimately publish out your final data set. And as I said, this is Trifecta's sweet spot. So we are the link between your data and your analysis, allowing you to get the best analysis out of your data. And one of the cool things that you'll be seeing in Quoc's demo is that you're actually able to do this without any coding skills at all. So we're finally putting all of these new digital sources in the hands of the analysts who need to and want to work with that data. So focusing in on Royal Bank of Scotland, their particular Customer 360 use case is centered around working with web chat data. And so the business challenge, and one of the things that the group at RBS likes to tell us, is that they wanted to personalize their customer experience. And in order to do that, they need to understand all of the interactions that customers are having with the bank. The particular data point for RBS is that customers were launching at least 250,000 chats per month. That's a lot of web chats. And you can imagine the massive amount of interesting data you could get if you were able to analyze those web chats. However, the big challenge is that prior to implementing the data wrangling solution with Trifecta, Royal Bank of Scotland was only able to get through 200 chats every month. So if you're getting 250,000 chats, you can only analyze 200. That's less than 0.01% of the chats that you can deal with. So you can imagine all of the insights that you're leaving on the table, all of the interesting patterns that you want to discover, but you simply can't because there's not enough resources and time to get through all the chats that are being generated. Also, there was valuable time taken up by manual processing. So the actual way RBS was dealing with these 200 chats was through reading them. And what they wanted was to have an automated way to parse through the chats and find interesting elements in them. They didn't want to have their agents going through 200 chats manually and writing down what they think was interesting. This is not scalable. So stepping back a moment, I wanted to give you a brief overview of how Trifecta was deployed at Royal Bank of Scotland. So what you see here is a logical architecture of their data lake. You can see all of the sources that they were bringing into their Hadoop data lake. These are traditional transactional data, banking, credit cards, mortgages, payments, as well as all the new social interaction data, including web chats. Once this was ingested into the Hadoop data lake, Trifecta was deployed on top of Hadoop, which allowed the analysts to access, structure, wrangle the data, and ultimately push that downstream so that the business can use the final data models for reporting analytics and producing advanced statistical data science models. So what was the end result here? You can see highlighted in orange the major benefit that Trifecta provided for Royal Bank of Scotland. And this is that instead of processing 200 logs every month out of the 250,000, they're now able to wrangle 100% of the logs that come in the same month that those logs arrive. Another interesting data point is that actually developing the process and the script to wrangle these logs only took a total of 2 weeks. So if you compare that to the months it took to manually read through, and that was a month that would get repeated over and over again for perpetuity, a single 2-week development process, and you can then deploy and let it run. Fundamentally, and the most important business benefit, is that Royal Bank of Scotland now has insight into what their customers need when they're chatting about it. And this is incredibly valuable for the organization. So I wanted to share a quote that we received from the head of Royal Bank of Scotland's web chat operation. And what Akshay says is that the dashboard that they've created with the data they wrangled in Trifecta is transforming the way he runs his business. It is improving the customer-centric approach in our chats, and it is showing in the output that we now see. So being able to combine the new digital voice, this digital data generated from web chats, with existing customer transactional data has allowed RBS to have new insight into what their customers are doing and respond to them very quickly. So I wanted to give you a teaser for what you'll see in the demo. And these are 4 of the ways that you'll see Trifecta provided major benefits for the Royal Bank of Scotland analysts. So the first is inline profiling. As you're working with Trifecta, what you'll see Quoc do is the tool immediately surfaces quality problems as you work. The second is sampling and scalability. 250,000 web chats a month, that's a lot of data. And in order to work with that in an interactive manner, Trifecta promotes a sample to scale workflow so that you can, in real time, very responsively wrangle, structure, and profile your data. And then, when you've developed your script, run that at scale. The second, or the third and fourth of the major Trifecta benefits for the Royal Bank of Scotland analysts are structured transformation previews and transformation suggestions. These are fundamentally what enables business analysts to use Trifecta without code. And you'll hear Quoc talk quite a bit about this soon. With that quick overview of the Customer 360 use case at Royal Bank of Scotland, I'm going to hand this over to Quoc, who will walk you through the demo.
Yes. Hi. Before I jump into the demo, I want to kind of show and discuss how Trifecta, kind of the data flow between Trifecta and Hadoop. And in this slide you see here, we walked you through the process of, first you register the data from the cluster into Trifecta, and then you're able to bring in a sample into our interactive interface to be able to wrangle the data, prepare it in the shape that you need so that you can use it for analytics and so forth. When you're happy with the data that you are wrangled, you can push that logic down and execute on the cluster on the larger data set. And as you're doing that, you get results and understanding if there's outliers or anomaly in your data. If there are, you can go through this workflow of revising that and then rerunning it so that you get the data prep that you need for whether you're using analytics tool like Tableau or Zoom Data, or just using R or other advanced analytics technology in your platform. All right, so with that, I'm going to take control of the WebEx and demo the product to the audience here. All right, I'm sharing my desktop now, and you should be able to see the Trifecta interface on screen. And so before I jump into working with the product, I want to kind of explain the data that I'm working with. And as Connor explained earlier, one of the data source that I have access to, which I want to extract out valuable information, is this particular log here called web chat. And as you see here, it's coming off of the website. It contains information about the person who logs into the website, what chat information they did, and so forth. So it's somewhat complex, very, very difficult for someone who's not technical to get to the features and information they want for analysis. All right, and then of course the idea is to take this raw data, get the features and information you need for analysis, and then join that to a more standard data set that you may already have and you're familiar with, which is a customer database coming from your website. So this particular WebLogs database shows, and it's very structured, it shows the user ID, their session information, whether the status of that particular session, whether it succeeded or not, and as you can see in Trifecta, this is a very familiar look of rows and columns. Now, for the folks who've never seen Trifecta before, this is what we call the transformer page. It gives you the ability to interact with the data, as well as visually see the statistics and information about the data you have, so that as you discover this data, you can actually take action and profile that data to be able to be more intelligently prepping your end result, which is your composite prep data set. In this scenario, my goal is to take this particular structured data set and join it with the data the raw data I'm going to wrangle, and also join that with a Twitter data set that I got from the Twitter feed around my customer, my company. All right, so the idea here is, so let's go back to the structured data here. This data, again, familiar. Most people think structured data is very clean, but a lot of times a person like myself, this might be the first time I see this data. It's been given to me, and my first time having access to it. Trifecta gives you information right away about the different dimensions that I have. Okay, so you see here we have these histograms that plots out the different buckets and categories of data in each column. We also infer the data types so that you're able to get a quality bar on whether it's consistent to the data that is in that particular column. So you see here status 1, Trifecta has provided a data type being string, and therefore most of the data are string. Now, we support a multitude of different data types. We have primitive data type, string, integer, decimal, and Boolean, personal ID information like social security number, phone number, email address, credit card, and gender. These personal ID information, we actually apply logic to check the validity of that data. For example, credit card pattern. Not all 16 digits are credit card. We actually apply the algorithm that checks whether it's a valid credit card or not. We also support more complex structures like maps and arrays. Also web information like IP address, URL, HTTP code. We also provide dictionaries like state and zip code that that will validate whether it's a valid state or it's a valid zip code, and then date time file format as well. Now, lastly, we also offer the ability to provide custom types. So certain organizations might have their own algorithms of creating data types. Trifecta offers that facility for you to either load the dictionary of your the valid values or provide regular expression pattern that can be used as a custom type in Trifecta. Okay. Enough of that. Using that data type, Trifecta gives you this quality bar, and as you see here in status 2, or even actually in last completed step 2, you see we visually provide this bar that has 3,000 plus valid value, which is highlighted by green. You have 1,700 plus missing values highlighted by the black. And then, of course, there's some 5 mismatch value here by the red. So as a user, I'm drawn to this particular red, and I'm going to click on it. And this interaction results in Trifecta highlighting the different rows that has those mismatch value. You see here in the grid the different rows that has that. We can zoom into those those rows, and as you see, they are random symbols. And the interesting part and the value that Trifecta brings to the end user is will suggest transformation logic that can be applied based on that interaction. So when I highlighted or I clicked on the little red spot, we highlighted the problem area, and also we suggest what you can do with it. So one of the things is be able to keep all the rows that have those values, or actually in my demo, I'm actually going to remove them. And so clicking on this particular visual card called suggestion cards, you see that clicking on that, we highlight the rows being red, indicating that I'm going to delete it from my data set. So I'm going to add it to my logic. As you see, interactively, it would immediately respond that the data has been removed from the column, and I'm happy having those outliers. But I do see missing values in status 2 here, so I'm going to click on that. Now, again, we highlight those rows that have the missing value. We brush and link across the other dimensions in those histograms to see the correlation between one where the missing values are to the other columns. But more importantly, again, suggesting what you can do based on that suggestion. In this scenario, I'm actually going to set the value to be NA, or by modifying it, saying incomplete. So I can type in the value as needed. So now I've revised my status 2 where missing values means incomplete, so that my models downstream don't break. The other thing with Trifecta you can do is actually get in more in-depth and double-click into each histogram by seeing the column detail. So now, as you see, when I modified it to be incomplete, I can see how many of the rows and graphed out here in this visual profile that we provide. I can also click on other interesting dimensions like timestamp, and Trifecta will give you statistics on outliers, on mismatch value, top value, statistical summary around the data in those columns. And we also, again, plot it out visually here so that you can see if there's any anomaly in your data distribution. And if there were, I can actually interact with the visualization and to create transformation logic based on that interaction. Okay, but at this point, with this particular structured data set, I'm pretty happy with the data I've filled out. I'm going to save it so that I can leave it so that I can use it to join with the structured data, the data I'm going to structure from this particular log. Okay, so the process of logging that, similar to the PowerPoint I mentioned, I'm going to go into my project here and be able to create a new data set. Okay, and I can go and I'm able to upload data from my desktop. I can also navigate Hadoop HDFS file system to get to the data set that I want to work with. Okay, I can also connect to S3 buckets to get the data that I may have stored in Amazon AWS S3 storage. I can also connect to Hive so that I can get to relational data that's been ingested into the cluster and surface as tables that I can query. And I also can connect to SQL sources like SQL Server and Oracle and Postgres to bring in reference data so that I can join with my composite data set. Okay, so to take the demo, I'm going to go and search for that particular web chat I was talking about, and I'm going to create that data set. Okay, so I'm adding it to my project, and as I load it, you see that I can go to my project and go and transform it. Now, when Trifecta first brings in the data, again, as Connor mentioned, we work on the industry-accepted technique of sample to scale when it comes to working with large volume of data. Trifecta has brought in the head of the file, which is the first 500K, and then we're also running a random sample collecting a reservoir sampling of unique value in the data set. Okay, now what that gives you is the ability to see the data quickly and be able to start structuring and working with that data. Again, seeing the histogram here, you see there's a consistency in unique values for individual rows there, but then I'm drawn to this one outlier, which if I click on it, shows that they are chat export. If I zoom into those 4 rows, I see that they're all kind of the header of chat export that got concatenated this log. Now, I don't need that data. It's kind of not necessary in my analysis, so I'm going to go ahead and remove it from my data set. So you see, using the histogram, I'm able to get to quickly the outliers that I may not need for my data. Again, now looking into this particular messy data that I have here, I see that there's a bunch of name value pairs and so forth. And for this demo, I'm going to go and start structuring it. And by doing so, I'm going to highlight one of the key value pair called geoinfo here. And then I'm going to highlight the word source. Just selecting and swiping over these values, what happens is Trifecta will see what I'm doing, infer based on the data and the structure around that, and based on that context, suggest transform like extract key value. So this key value is a pattern that got built up based on my interaction. I can mouse over a different option, and the second little dot here is this option that is more precise and I'm actually going to use because it uses the delimiter ampersand. I'm going to add it. I can see the preview over here in column 2. It looks like all the key value has been extracted out, and it looks correct to me. I'm going to add that to my logic. When I say I'm adding to my logic, what is happening is I am building this particular recipe you see on the right. These are steps that are being applied to the data. These transformation logic is written in expressed as a domain-specific language called Wrangle. It's easy to read. It applies to the data, and it's great for managing and understanding what's happening to the data. In context, we use this to understand the lineage of the data. Okay, so as I've done that, I have a map of my data. I basically converted that single row of log into key value pair. And with map structure like this, I can actually click on the column name and be able to unnest individual keys and taking them out into columns. So I went from a row of data where the key value pair to columns and rows of each of those dimensions. You see here it looks correct. I'm going to add that to my logic. Okay. Now, since I've unnested all the keys, I'm going to go ahead and drop the raw column, and I have my data somewhat structured. But I notice over here there are more complex information in here. I see there's again some key value pair embedded in a bunch of timestamps, which represents the chats that are being logged in a particular web log here, or chat log here. Okay, so what I'm going to do is split it up into 2 sections by highlighting this little red dot, which represents a space. Now, highlighting that, Trifecta realized there are other dots in a space in the data, and it will suggest splitting on that. But actually, I'm going to be more precise, and I'm going to pick one of the more precise options, which is this one here, and you see I am going to go and split the data into two columns based on this particular pattern that I built up, which is before the bracket. I see the preview of the two split columns. It looks correct to me, and I'm going to add that to my logic. So now I have two separate distinct columns, one with the key value pair, again with the key value pair. All I have to do is highlight one of the key and another sample of that key, of another key. Trifecta, again, will suggest key value that I can extract into, again, a map of key value pairs. Okay, so I can drop GO1 because I don't need that anymore. I have all the key of an IP address, ISP, latitude, longitude, and real-time session ID, and so forth. Okay, again, I can unnest that into rows and columns also. So I just highlighted the ability to work with these complex nested map structure, but in this scenario here, I have timestamps of the individual chat. What I'm going to do is actually highlight the timestamps, and then again highlight the timestamp over here. Trifecta will recognize this pattern for timestamp, and it's able to offer different suggestions. And in this scenario, I'm actually going to extract the list of timestamps that allows me to pull out all the timestamp for each one of those line of chat. As you can see here, I have all the timestamp in an array, a list of them. Okay, it looks correct. I'm going to add that to my logic, and now I have the beginning timestamp and all the timestamp for every single chat. I'm going to go and try to unnest the value from that list. And this particular suggestion that came up, and this particular card talks about the ability to unnest the first key and the last key, which means I'm able to unnest or pluck out the first timestamp and the last timestamp from each one of those lists. Okay? What that allows me to do is then calculate how long each chat session is. By knowing the first timestamp and the last timestamp, I'm going to go and derive the length of chat time. So easily to do that, you just highlight the column and then highlight the other column, and you're offered the ability to derive. And in this scenario, you see that I'm able to derive, and in this particular formula, if I look at it here, it says deriving a date diff between the first key, the first timestamp, and the second timestamp based on the second. I can name that chat time, and you see the preview, and it looks correct. So as you can see, I've worked with this complex structure, which is a list of values, be able to pick out the keys that I want, be able to form a derivation to bring out the chat time, which I'm going to use for my analysis. Okay, so with that, I'm going to go and drop the raw columns I don't need anymore by just purely highlighting the individual column. And now I'm able to drop those columns as needed. Okay. Over here, I noticed that the URL is the source is a URL, and I'm actually going to try to pull out the URL parameter question. And Trifecta makes it real easy for you to do that. All you have to do is highlight one of the key here, and we recognize it being a URL, they're going to have parameters in it, and highlighting the parameters will result in me wanting to extract out the individual URL parameter. And that looks correct, and I apply that to my logic. So now I just pulled out the URL parameter question, and I have all the values for each one of those questions in the URL string. Okay. Now I've got this particular chat log structured from this raw file, somewhat difficult to wrangle and look at, into the structure format. then I'm actually going to go and join that with my customer database I showed you earlier. Okay, and now you'll see that we'll go into the process of the join process. I get the preview of that. I'm going to select the join keys. By clicking on that, I notice that we have inferred the timestamp to being the join. I'm actually going to go edit and pick the customer ID and user ID, okay, and be able to save that, right? And I can also add an additional join keys as well and be able to do based on session ID and session ID. Is that correct? All right. Nope. Again, Trifecta suggests different transformation logic for you. As you see here, we'll have a customer ID and session ID being joined, and I'm going to save that particular join key condition. We support different types of join, inner and outer, and I'm going to bring back all the dimensions that I need to work with and add that to my logic. So as a user, I'm offered the ability to easily join two different data sets, pick the keys. Trifecta will help you infer that based on the context of the data. Here I have the composite data set now. I can start, go and generate that data set by purely clicking the run job. It will choose the file format I want to output to. I'm able to profile that data, and I've done that already before. And as you see here, a previously run job. Trifecta will profile the data at scale, give you the statistics of each of those dimensions, will surface any outliers that you may not take into account, and you can revise it. But if I'm happy with this result, I can actually go ahead and publish that, export that result by publishing it to Hive so that you can use SQL tool to query it. You can append an existing Hive table as well. You can reuse the data file that you created as a source in Trifecta, or quickly download as a TD file to visually try that in Tableau desktop. Okay. Now I'm actually not done. I'm actually going to go and wrangle the Twitter data so that I can get my customer sentiment and see how they are in relation to my entire composite data set. So Twitter data, again, is very, very complex. It's a nested file format called JSON. JSON is a current modern structure that a lot of API uses, where you can embed a lot of information. Trifecta makes it easy for you to work with. So the Twitter file comes in with two different keys there, Twitter info and user info. I could unnest that by, again, clicking on a column name, and I'm offered the ability to unnest that into those two different columns. Again, since they're heavily nested, you see that there are additional maps of JSON objects here. I'm going to go and pluck out key things that I want, and I care about Twitter text. So I just click on the key for Twitter text, and you see that I'm extracting the text from the Twitter feed itself. Okay, and for the user info, I'm going to pluck out the username, user ID here, and because I'm going to use that to join with my customer data set. So now I have the user ID, I have the Twitter text. I can go and start working with this unstructured data in a couple of ways. First, I can start doing extract features around customers' words, keywords that they use. For example, if I don't like the word then and so forth, I can highlight that and extract that. But more importantly, I care about the sentiment. So with Trifecta, you can extend Trifecta to work with UDF, or user-defined function, that can be written. In this scenario, I've written a sentiment analysis user-defined function that I'm able to apply to the Twitter text that will go off and generate a score for each one of those texts. I add that to my logic. What happens is each line is sent to the Twitter text, and you'll see we bring back a score for the sentiment. Again, for this demo, I care about the negative sentiment, so I'm going to pluck out the negative keys, and you see here, these are all the negative keys, a negative score for each one of those texts. Then I'm going to actually just care about the high negative values. So interactively, I just highlight in the histogram all the high scores. We build up the logic to keep all the high negative value. So I've applied that. And you see here in this particular text, a lot of the negative, I've never had internet, and so forth. There's a lot of negative text in it. Okay, so all I have to do now is go and join that data with the data I was working with, and you'll see, again, we'll go into the join process and be able to create that composite set with my Twitter info. Now, as I join this, you'll see the join keys being inferred. This is a similar step. I'm going to go and, actually I'm going to change my mind. I'm going to start doing additional transformation. So I'm going to go back to my customer chat here and do a aggregation, because I noticed that each of my customers may have multiple entries here. I'm going to go and do an aggregation. And our aggregation tool makes it easy for you to drag and drop the dimensions that you want to aggregate and be able to quickly build out any type of analysis you want very easily, right? And you can do a count of the IP address. You can change your mind and revise that. You can build that aggregation up very quickly and then run the job, again, produce the output that you need. Again, in the scenario here, you get to the job results, and then you can export a TDE. In my demo, I've already created a TDE that will populate into Tableau here, into this Tableau desktop that I can build different charts based on the dimensions I built, and be able to answer questions that I care about. For example, which are the most popular questions on my website, right? I can build dashboard as well. And now, Trifecta does not do these dashboarding. We're a data preparation, data wrangling tool, but we integrate very closely with Tableau and other visualization tools like Zoom Data and Click and so forth, where you quickly build a nice viz that you need for your analysis. All right, so that's sort of end-to-end flow of what Connor kind of described earlier in the session about how one of our customers is able to take these complex structures, different sources, be able to join them together to be able to perform analytics on top of it. Okay.
All right, so thanks, Quoc. I think we wanted to take some time now to answer any questions that might have come up. So let's see. Okay, so the first question that came in, you went through web chat data in the RBS example. What other types of data can customers use Trifecta to analyze? Quoc, do you want to take that one?
Yeah, I mean, Trifecta is designed to work with a lot of complex different data structure. We can work with flat files, we can work with CSV file, we can work with JSON Avro file format. We can connect to different sources like Hive, SQL sources. So pretty much majority of the data that you would typically have and typically have in your big data platform.
All right, so I see another question that's come in. Are there any metrics you can share about time savings customers see when using Trifecta compared to other data prep tools used? So that's a great question. What we've seen, and actually one of the statistics that one of our customers has given us is that they've actually been able to reduce their total data prep time by 90%. So that's a huge time savings. I think it's also something that we saw in this RBS use case where they went from needing to manually scrub a small portion of their web chat logs in a month to being able to very quickly in 2 weeks produce a process to analyze all of those. But the official final number that we have is 90% time savings.
Oh yeah, there's another question is, does Trifecta have a free trial? We do. If you go to our website, you should be able to download our free version of our enterprise product called Trifecta Wrangler. It runs on your desktop and laptop, on Mac OS and Windows. You're able to run majority of pretty much all the transformation logic you want on data on your desktop and laptop.
All right, so one other question is, who are the primary users of Trifecta? So the interesting thing about Trifecta, and you may have noticed this during Quoc's demo, is that it supports a variety of different types of users. So the most frequent users that we see are the less technical business analysts and data analysts. So these are people who know the data best, know what they want to do with the data, but aren't necessarily proficient in coding. And so for those types of users, the predictive transformation, the way Trifecta uses machine learning to infer what you want to do with the data, really empowers these users to use their data and to get it into the format they want. Sort of our other subset of users is that more technical set. People who might know SQL, might know Excel, might know a bit of Python. But for these users, the real differentiator and the real value of Trifecta is the immediate previews that show you the result that every transformation has on your output. So you can very quickly and without needing to wait understand instantly what's happening. So primarily, to circle back to the primary users question, primarily business analysts, but we also see people like data engineers and data scientists also getting a lot of value out of Trifecta.
I think the next question was, how is Trifecta deployed? We're a very lightweight deployment on Trifecta. The current enterprise version is deployed typically on an edge node part of the cluster. Very lightweight. We don't actually have to be deployed on all the nodes, just on an edge node. And so very simple. A lot of customers appreciate the simplicity of our deployment. So when we do deploy in complex enterprise customers' environment, we adhere to all the security frameworks that is deployed with those clusters, whether it's Cloudera Sentry or Hortonworks Ranger. We adhere to all those security that's been deployed for most typical enterprises.
So I think it looks like we are out of time. So thank you, everybody, for joining us today. If you are interested in learning more about Trifecta, you can visit our website, trifecta.com. And I know Quoc mentioned our free downloadable version, Trifecta Wrangler. If you want to give that a go and start playing around with the tool yourself, you can go to trifecta.com/start-wrangling. Hope everybody has a great day, and thanks again for joining.
Thanks for your time.